So we're going to talk about graphing exponential functions and logarithmic functions. On Friday, who remembers graphing logarithmic functions on Friday? Jeff remembers. Caleb remembers. They kind of look like this, right? It kind of look like the hill that you hate starting to go up, but it got better with time, right? That hill sucks at first, right? But after a while, it's manageable, okay? Remember this. Remember this. Because we're going to come back to that. But first, let's do the opening exercise for this table. The opening exercise is basically to fill out the table. So, I want to fill in my y's for when x equals -3. So what is 2 to the -3 power? Let's do fractions. I like fractions. 2 100ths? 2 to the -3rd power, which is, how do I do negative powers? 1 over that, right, Sophia? So, and then I cube it. So 2 to the -3rd power is going to be 1 over 2 cubed, and 2 cubed is 8, so this is 1/8. So what is y when x equals -2? Remember, the negative flips it. When I say flip it, I mean it takes the reciprocal. So now I got 1 over 2 squared. And 2 squared is 4, so it's 1 over 4. 2 to the -1 power? What's 2 to the -1 power? 1/2, thank you. 2 to the 0 power? Ooh, yeah, 1. To the 1 power? 2, 4, and 8. We are on point. So then over here, we got graphing in our future, don't we? Yeah. What's the point for this? Well, x and y, right? So -3, comma 1/8. -2, comma 1/4. -1, comma 1/2. 0, comma 1. 1, comma 2. 2, comma 4. And 3, comma 8. I'm going to play with my new toy here. And looky here, I got my dual page display up because we're going to graph these points on the next page. I think I'm going to need my skinny pen for this. Should I do it in red though? Let's do it in red. So when x equals -3, y equals 1/8. That's, yes? Am I right? Or is that a little high up? Is that really little? How dare me? Is that better? Well, I can't. Is that better? I need some sort of precision, right? I need some sort of precision. I know I'm being a goof. I'm sorry. Is that about right?
Yeah.
Okay. When x equals -2, I'm at 1/4. A little bit higher, but not much. Is that too high up? Good enough for government work? All right. When x is -1, y equals 1/2. All right there. And then 0, 1. 1, 2. I'm going a little faster now. 2, 4. Yep. And 3, 8. And now I'll use my skinny line to connect the dots. Taylor, line test. About there. Okay, good. All right, now I'm going to leave. I'm done with the table. I'm going to turn my dual page display off. We're just going to look at this. Now, it says sketch the diagonal line x equals y. What does that mean in English? What do you think, Caleb? When x equals 1, y equals? When x equals 2, y equals? When x equals 3, y equals? When x equals 3.1415926? Y equals? Pi. Good. Good. So I'm going to do this in blue. Put dot there, put dot there, put the 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 dot there. You notice I'm not building a table for this. Put a dot there, put a dot there, put a dot there, put a dot. I'm not building a table for this, am I?
No, sir.
Let's just. Yeah. Oh, wrong way. And let's extend that, bam, like that. There's my line, yes? Now we built this blue line that I've written up. That represents a function that has a special name that we call the identity function. Okay? But you don't need to know that right now. Now we're going to sketch we did this part, and then we're going to say it wants us to do this. It wants us to reflect the graph of y equals 2 to the x power across the line. What do they mean by that? What do they mean by that? Here's what they mean by that. Check this out. If I take this point right here, right? I'm going to do, what color line should I do? Let's do an orange line. I go straight across. Is that about perpendicular, you think, Ethan?
Yep.
All right. And I want to go the same distance across. I want to go down to -3, though. Do I want to go down to -3? I want to go the same distance across, but perpendicular. About right there. I want to put a green dot there. Don't worry, I'll get rid of that. Why? There it is. Thank you. Put a dot right there. All right? And then I'm going to move this guy right there. Now I want to go the same distance here and here. So I'm going to put a green dot right about there. Does everybody see what I'm doing? I'm measuring the distance from here, from my point to the line, and I'm going the same distance over. Okay? Same distance each way. And you're wondering to yourself, you're saying, self, why are we doing this? Check. Just bear with me. Yes. Yes, you can. They're on that little table back there. So, for this one, Trey, measure here, measure there. Put a dot. Again. Measure, measure. Put a dot. Oop. No. right there. Measure. Well, let's do this. Measure, measure, dot, measure, measure, dot. Now I'm going to get rid of that orange line there.
Perfect.
It's not perfect. We are not good artists, right? I'm not a good artist anyhow. But when we do this, what do we got?
You just suppressed me.
What did we do on Friday? Doing the same thing opposite. But what does it look like? What did I tell you to remember over here? What did we graph on Friday? All right. I'll have to do it this way. I'll have to use Desmos. So, Desmos, start graphing. Check this out.
Check it.
Y equals 2 to the x. Here's my red graph. And then y equals log where's my there it is.
Jody, where are the beats?
You
got rid of your
baseball swing, fingers, all that jazz.
Are they good sound?
That's how you do it.
There we go.
Look at that.
So this is the representation of what I just did, except in Desmos. Right? And what are my equations? Yeah. What are my equations? I got y equals 2 to the x. I got my green equation is y equals x. That's the identity function. But look at my blue equation. Log base 2 of x. Okay? What does this mean to you? There's a relationship there. We understood the relationship before, right? But we understood it in how to play with an equation. Now we understand it graphically. Okay? That's the whole point to this lesson today. That's the whole point of this lesson today. Now, good news. Good news.